Hello once again, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek into my personal experiences. This is a channel designed with you in mind. Let us dive into today's lesson. In this series of videos where we are looking at the ultimate guide, if I can go back here to say we are looking at the ultimate guide to organic chemistry for grade 12, and in this video we are now moving on to look at alkanes. We have done quite a number of videos here where we introduced from organic chemistry and looked at different lessons, so it then forces you to go back to each and every lesson that I've done. But as I said, always guys, subscribe so that it becomes easier. If you are subscribed, notifications are always coming, but also it's easier for you to follow up because I'm calling one lesson 2, lesson 3, and so on. So in this video we are moving on to look at alkanes. Now, one also of the important lessons now when you start building up on your organic chemistry. Now your syllabus say we must limit up to 8 carbon atoms. So as you are reading, ensure that whatever you are doing is got 8 carbon atoms in the chain. So now, looking at this, we are going to look at what we mean by saturated hydrocarbons, as well as the naming of alkanes, the structural formula, the molecular formula, and the condensed structural formula, as well as the general formula. Now we are dealing with what is called alkanes. The first word here that is coming is the word alkanes, and we are saying these alkanes, number one, what are they? They are saturated. And what do we call the term saturated? We said number one, it says these are hydrocarbons. Number one. Number two, they contain only single bonds. Alright, so if you're saturated, it's a hydrocarbon that contains only single bonds. So an alkane is a hydrocarbon that contains only single bonds. And we say they are what? They are saturated. The next one is the naming of alkanes. Now, in this naming of alkanes, I want you to be sensitive here. This is what I want to bring to your attention. Now, alkanes is the beginning of the naming. We all start with alkanes. In organic chemistry, when you start naming, you start with alkanes. And that naming, this word alkanes, it's the homologous series. Homologous. I'm drawing this. This is the homologous series. What is a homologous series? We're going to get it right definitely, but it is a group of atoms having or differing from each other, we say by the CH2 group, or having similar chemical characteristics. So we're going to get the actual definition that I want you to hear for your exam. But the homologous series here is the alkanes. So if I say alkenes, it's another homologous series. If I say alkynes, it's another homologous series. Later we'll look at alcohols, it's another homologous series. We'll look at carboxylic acids, it's another homologous series. So alkanes is the first homologous series we're going to deal with. And as you see here, I did say naming of alkanes, the homologous series. Now guys, once you master the alkanes, you are done. Alkanes are what I can say the foundation. These are the bedrock or the backbone of all the naming that you are going to come up with. So you master this, you are done. So we say up to how many carbons? They say you're going to limit up to 8 carbon atoms, remember. So I'm going to then say let's start here to say this is carbon 1, this is 2, 3, 4, 5, and then I've got 6, 7, and 8. We are going to name these. Again, when you master them, you're done with the rest. So I will encourage you to cram this, master this, recite this. Get yourself some time just now after this lesson Get yourself some time to start reciting this. Let them be in your system. If I just tell you what is the alkane with 4 carbon atoms, you must be able to tell me at an instant. With 7 carbon atoms, you must be able to tell me at an instant. But there is a hint before I give you the names. The hint here is also to refer to shapes. You'll see what I mean when I say refer to shapes. Your naming of shapes. That is your geometry here. But now let's start with the first one. The first carbon with carbon number 1. By saying 1 means it's carbon number 1. We have what is called methane. Number 2, we have what is called ethane. Number 3, we have what is called propane. Number 4, we have what is called butane. Number 5, we have what is called pentane. Number 6, we have what is called hexane. Number 7, we have what is called heptane. Number 8, we have what is called octane. Let me start from the back going up. Now, octane, remember the shape? It's 8 shape, an 8-shaped object is called for example, an octagon or an octopus. Octagon is an 8-sided shape. Octagon, from the word octagon, you can get octopus. It's got 4 legs, all those. So this is an octagon. Even here, 7-sided is heptagon. See what I'm saying? Some of this shape. And then 6-sided is hexagon. And then 5-sided is what? It's pentagon. See the shapes. So from these 5, 6, 7, 8, already you've got 4 that you know to say. The 5-sided, pentagon, pentane. 6-sided, hexagon, hexane. All that. Okay. So you can use that to your advantage. The second thing I want to bring to you, let me erase here, is when you're naming alkanes. So I'll come up with a name here again. It's al, and then look at this. I'll write the word cane. Look at what I just added, cane. You will see it in every shape here, or in every molecule. Number 1 is methane. There it is. Ethane, A-N-E. We are adding a, so it's meth, eth, prop, but, an, pent, an, hex, an, hept, an, oct, n. You see that? So that's why I'm saying oct. You get the octagon. Hept 7, hex 6, pent 5. Then the but, prop, eth, and methane, they're the ones that you can now try to master them. Guys, this is what we mean by the what? By the naming of these alkanes. I said recite them. They are the bedrock, the foundation of every homologous series that you're going to be naming. We are going to be looking at what they call IUPAC naming later. They use the word IUPAC. International Union of Pure and Applied Chemistry, IUPAC naming. What does it mean? It means the International Union of Pure and Applied Chemistry. We're going to be looking at the actual naming of compounds, and is linked to this homologous series of alkanes. The next one, the structural formula of these, and the molecular formula. So I'll start here going backwards. If you're talking about methane, let's start with the molecular formula. It's CH4. Why? Because you said carbon can carry like this. This is carbon. It's got methane is carbon 1, remember? So it has got 4 bonds. So you've got H, 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 and that. That's the first one. Then after that, what do you have? You have got ethane. So if you look at the molecular formula, it's C2, and then it's H what? It's H C2H10. Am I right? So let's start with the structure, and then after that we come with the molecular formula. I think it's much better because here it's 1, 2, then I've got hydrogen, 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 hydrogen. So let me correct that. It's C2, actually H6, not 10 there. Are you seeing that? That was what? Ethane. Let's come to propane. Propane is 3. So it's I'll take it there to say 1, 2, 3. And with this 3, you can see now it's hydrogen, 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 and hydrogen. Remember, hydrocarbons, carbon and hydrogen atoms only. Saturated, it has got only single bonds. And then you have got also now what we have as the molecular formula. How many carbons? This is C3 and then H3, 6, 7, 8. Are you seeing that? Next one is what? Is our butane. Let's take butane here. Butane has got how many? 4. So you have got 1, 2, 3, 4. And then what you have, you put these. This is what students do now when you're getting comfortable. You do this. And then after you do this, you leave it like that. They'll penalize your marks because we don't know what is in here. Don't assume we know that they are hydrogen atoms. They will penalize you a mark for every hydrogen that is missing. So some of you end up leaving your answers like that because you think you're in a hurry, the teacher is going so fast. But don't forget, you need to, every time, it's only complete with the hydrogen atoms. So if I'm doing it, why can't you? So don't leave it blank. Always add it. See, these are hydrogens that are very important. Don't leave it blank. Now, with this one, what do I have for butane? It's C4 and then it's H10. All right, there are 3, 4, 5, 6, 7, 8, 9, 10. Now, your duty now. Do for me pentane. Can you do for me pentane? How does it look? And then pentane is how many? It's 5 carbon atoms. Can you do for me pentane? What you do? Pause this video and draw your structure for pentane and tell me what you're coming up with. Then compare. Let's compare. Now let's do that. Pause this video right now and draw the structure of pentane. And I'm going to be drawing it now here. Guys, if I say pause, just do that. Don't look at me. Why are you looking at me? I said pause the video. And then if I was near you, I was going to give you a slap because you don't have pause. I'll give you a slap to say wake up. You are not a spectator. You are also, you must be able to participate. Don't spectate like you're watching a soccer match, And I'll be the best player in that soccer match, I think. I mean, in that soccer match. But listen, guys, I'm joking. Don't spectate. Let's work together. So pentane, how will it look like? 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is the structural formula, the skeleton. Then don't forget, important is to add the hydrogens. I know some of you, as you are becoming the experts on tabacon, the experts, you start saying, I don't need to put those, I don't have time. Guess what? The marks will fly off the window also if you think that you are now the expert. So this is the pentane. What is it? C5 and then H12. Are you seeing that? Then do this one for me also. Do for me hexane. Can you do that for me? Hexane, 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 hexane. What is hexane? It's 6 carbon. Pause this video, you do 6, 7, 8. Hexane, heptane, and octane. Can you do that for me? Pause the video and do these 6 because I just want you to compare your answers. You pause and then after that, it's not difficult, guys. Pause and then do them and then compare. Let me do that if you have done what I told you to do. Hexane, it's 6, 2, 3, 4, 5, 6. Then I do that. See, the aim is to maintain. Look at it. The first one, carbon number 1 has got 3, and carbon number last will also have 3. So you'll have 3 on the first carbon and 3 on the last carbon. Making sense to you? I repeat again, you have got 3 on the first carbon, 3 on the last, and then after that you add 2 hydrogens in the center, 2 hydrogens, it's 2 hydrogens, and it's 2 hydrogens. Now what does it come to? You come here to the molecular formula, it's C6, and then hydrogens is what? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think that the next one is what? Is heptane. I asked you to pause this video so that you can draw. So heptane is 7, 1, 2, 3, 4, 5, I don't have space, 6 and 7. So it's 1, 2, 3, 4, 5, 6, 7. And then here it's, I told you it's 3 hydrogens here. And then this one has got 2. So the end always has got 3 hydrogens. Now we do that is that one and that. 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 And then what we have here, we have got C7H16. Now let's do the last one. The last one is octane. So with octane here, it's what? Octane is 8. 1, 2, 3, 4, 5, 6, 7, 8. See, because I've been doing so much, I end up saying, it's no reason for me to be having this. I'll leave it like that. And then I'm like, everyone, I'll know that is hydrogens. No. You have to be diligent. Don't leave out the hydrogens. When you get used to leaving out these hydrogens, guess what? Even in the final, you find students doing that. They forget that there are hydrogens that they must put in here. It becomes a habit. Actually, now what am I doing there? It becomes a habit where you are no longer concerned with adding these hydrogens. And then what is the octane? The octane here is C8 and then H what? 18, I think. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But I'll tell you why I'm able to do that. So this was what? The structural formula. We did the structural formula and the molecular formula. Let's look at the condensed structural formula. It's not difficult. We can start here. On the condensed structure, I'll use this one here. It's simple. CH4. On here, CH3 and CH3. This is the condensed structure. On this other one, carbon number 3, it's CH3, CH2, CH3. Are you seeing that? On the other one, what do we have? Now, that's when I want to show you the trick of this homologous series. I told you on this one, you can write it like this, CH3, then there is 2, CH2, CH2, and then you've got CH3. But you're allowed to do this, CH3, and then put a bracket, you've got CH2, you said there are 2 of them, and CH3. Are you seeing that? So this was the one with 4, but now look at this. When they're talking about the homologous series, what is it? We are saying it is a group of atoms which differs from the next, if you look at this, by the CH2 group. So from here to this one, if you add, say, plus CH2, you get this one. It's not making sense now, but look at this next one. I added CH2, you see, this one here was appearing there, you see that, and then this one is there, but look at the center, I added CH2. Again, from here, the next one, if I compare them, I've got CH3, I've got CH3, and then I've got one of the CH2, but look, I say plus CH2, then I get which one? I get this extra one. Are you seeing that? So it differs from the next by the CH2 group. That's the homologous series. And then we look at this one, which was hexane. Again, it's CH3, and then these are 1, 2, 3. So I put a bracket, I say CH2, there are 3, and then I say CH3. You see that? So there are 3 here. Previously there were what? There were 2. See, 2, now there are 3. On this one there are 1, 2, 3, 4. Here it's 1, 2, 3, 4. If I write the homologous series, it's the condensed structure, it's CH2, there are what? There are 4 and CH3. Do you see that? Why? Because it differs from the next. It was 3, now it's 4 by the CH2 group. And then the other one here, it's octane, it's CH3, CH2 brackets, there are how many? 1, CH2, 2, 3, 4, 5, there are 6. So it's 6 CH3. I think that. So we are moving, I think here, I was supposed to say 5 actually. It's 1, 2, 3, 4, 5. Can you correct that? This is 5. This is 5, please. And then on this one, it's actually 1, 2, 3, and 4. So it's CH4. Then let me check the previous one. It's 1, 2. Oh, I missed out this one, the pentane. This one is the one with CH3. So it's 1, 2, 3, and then CH3, and then I've got what? I've got 3 and CH3. You see, so 3, 4, 5. At the end of the day, it must match the number as well as the number of carbon atoms. So this is the condensed structural formulas, guys. And then the general formula now. I asked you to say, I'm able to tell you what is carbon number 10, what is carbon number 20, for example. I'm able to say that, but there is a general formula. Look at this. We're adding, remember, we said the next group divided by the CH2 group. So when you look at the series and sequences in your mathematics, this is the general formula. You've got CN H 2N plus 2. This is what is happening. This is the general formula. For example, if I wanted to say, tell me for butane, and butane is how many carbons? Butane is 4 carbons. Remember, it's in number 4. But 4. So now I know that my N is equal to 4. So I come here and say C4H2, my N is 4 plus 2, which is equal to C4H. Now 2 times 4 is 8 plus 2 is 10. Then you come here to say I did butane was C4H10. Where is this? Butane, where is my butane? There it is. My butane was C4H10. There it is. Okay, we can do, for example, here octane, it's C8H18, but octane is what? Is group number 8. So I know that if N is equal to 8, I'll come here and say C8H28 plus 2, which is equal to, for octane, C8, 8 means octane, and then H. Now 2 times 8 is 16 plus 2, 18. You see? They can actually ask you to say, what about a carbon where carbon number 20 with N is equal to 20? So you do the same, C, and they will tell you, tell us the molecular formula of a compound with 8 carbons. It is saturated already by saying saturated, and it's a hydrocarbon. You know that is alkanes. So you're like C20 H2 20 plus 2. Then this is C20 H, 2 times 20 is 40 plus 2, it's 42. Okay, so guys, this is how you can then understand the nomenclature. That's another word. You'll find this word here. What we're doing is called in here the nomenclature. The nomenclature of hydrocarbons, or in this case of alkanes. Guys, we've come to the end of our lesson here. Now in the next one, guess what? We are looking at alkenes. So we looked, remember these are hydrocarbons, and we said there are two types, saturated and unsaturated. Now we're looking at alkenes. Then I'm going to go through the process of, again, naming them, structural formula, molecular formula, condensed structure, as well as general formula. You don't need to miss this lesson because it builds up on the previous lesson. If you're not subscribed, this is the chance to do, so that you can get the next lesson and notification from YouTube. Remember to share, as well as share it in your groups, in your WhatsApp groups, in your Facebook. Just share. The more you share, the more luckier you also become in life, because it shows that you are a sharing spirit. You just want others to benefit as well. Thank you.